Hey there, ever wondered if the air conditioning on an airplane is just a placebo? I mean, you're 30,000 feet in the air, surrounded by sub-zero temperatures. Does it really work? As an aerospace engineer, I'm here to pull back the curtain on a system that's more ingenious and, frankly, more brutal than you probably imagine. Forget everything you think you know about keeping cool on a plane. This isn't your car's AC. This is survival engineering at its finest. We're talking about the aircraft's environmental control system. Its job is to keep the cabin at a safe pressure and, yes, a comfortable temperature. But how does it do it? Here's where things get interesting and possibly a little unsettling. It all starts with hot, high-pressure bleed air. This air is siphoned directly from the engine's compressor. Yes, you heard that right. We're starting with incredibly hot air to cool things down. Counterintuitive, right? Think of it as controlled chaos. That hot, high-pressure air is not something you'd want blowing directly on you. We're talking potentially hundreds of degrees. The initial step involves this searing air being forced through a primary heat exchanger. It is a crucial component where the incoming air is cooled, initially by using cold inlet air from the atmosphere around the plane. Even after this process, the air is still far too hot to be pumped into the cabin. This is where the magic, or perhaps the controlled violence, really begins. The secret weapon is the air cycle machine. This ingenious device contains a compressor and a turbine mounted on the same shaft. Think of it as a pressure roller coaster. The compressor dramatically increases the air's pressure and temperature once again. Believe it or not, this heat spike is key to achieving ultimate cooling. Why? Because it sets the stage for the turbine to perform its crucial task, rapid expansion. After its pressure is boosted, the air goes through the main heat exchanger. This time, outside ram air that's forced into the system cools the air even further. But the true cooling power comes when the turbine rapidly expands the air. It drops its pressure and temperature so dramatically that the air can actually plummet below freezing. It's like creating a mini Arctic blast inside the machine. Science fact: rapid expansion of a gas causes it to cool dramatically. It is a principle used in many cooling technologies. Now, pumping freezing air directly into the cabin would create its own set of problems. Imagine the chaos. So, the system cleverly reheats this supercooled air slightly. This prevents icing within the system and allows for efficient water removal. This is crucial because as the air cools, moisture condenses. The water separator then captures this moisture as liquid droplets. Think of it as wringing out a damp cloth. The final step is a carefully orchestrated blending process. The chilled, dehumidified air is mixed with filtered, recirculated cabin air. Then, for that perfect Goldilocks temperature, small amounts of that initial hot bleed air are added if needed. It's a delicate balancing act, a bit like adjusting the hot and cold taps in your shower. So, the next time you're cruising at 30,000 feet, remember the incredible engineering feat that's keeping you comfortable. It's a system that wrestles with extremes of temperature and pressure, all to create a safe and pleasant environment. It's a testament to human ingenuity. There's a quote that goes like this: "The only limit to our realization of tomorrow will be our doubts of today." It is clear that we need to eliminate our doubts so that we can continue inventing new systems for survival and comfort. If you are ready to uncover extraordinary insights behind aerospace engineering, consider subscribing.